Greetings, math hands. All right, so this is day 4 of chapter 2. So day 4 of chapter 2. And basically what we're doing today, math fans, is we're going to talk about inequalities. Okay, and many of you guys, again, you've seen this already, right? And equality is just with an equal to sign. So that's what we've been doing for the past several days. An inequality is with an inequality sign, right? So let's just kind of review. Got a couple symbols here. This guy, this guy, this guy, and this guy. So there are 4 symbols that we're going to talk about. Well, let's talk about the second one first, actually. So this is less than. And the way you kind of recognize that one is if you kind of turn your head and kind of angle it a little bit, it looks like an L. See, less than, right? Less than. So it's like L less than. And then the other one is greater. Now, I got a kind of a weird way to remember that one, but this looks like a G. Greater. So, yeah, I mean, it's okay, but greater than. Okay, so the other one, L, is easier to remember, and then just the other one is greater than. All right, and then these other two just mean this is like greater than or equal to. So greater than or equal to. Okay, and this is, of course, less than or equal to. Okay, so that's what those symbols mean. So let's talk a little bit about what these, just about the symbols here. So here's the deal. So let's put a number here. So we have 5, we have 7. Well, I learned it as a kid that the arrow always points to the smaller number. So I kind of like that. Arrow, this is kind of like an arrow, right? The less than sign, right? There's an arrow here. The arrow points to the smaller number. Okay? The arrow points to the smaller number. It's pretty mellow. Some of you guys may have learned it as the alligator eats the bigger number. I don't care. I mean, if you want to draw an alligator, I'm not good at drawing an alligator. I don't have enough room here. That's a horrible alligator. Okay, try and draw teeth, and it's eating the 7, even though it looks like it's got the 5 in its mouth already. I don't really know. Anyway, I'm just going to get rid of that. Okay, so get rid of that and get rid of the teeth here. There we go. Okay, so the arrow points to the smaller number. That's the easiest way to go. So let's kind of do a couple inequalities here, guys. So obviously if I did 10 and 3, well, it's going to point to the smaller number. So 10 is greater than 3 and 5 is less than 7. That's kind of how you say it, okay? Not bad. Let's put a couple negatives in there. That makes it a little confusing. So -2 and -1. How do you compare those? Well, be careful. Remember, if I drew a number line here real quickly, not very straight, but I said this is like 0, and this is -1, and -2, and -3, right? Isn't -2 less than -1? Because it's more this way in the number line. So it's less than. Kids get confused sometimes because they want to put the -2 greater than -1. It's more negative, guys. It's not like you're comparing positive numbers. You're comparing negative numbers. So -2 is less than -1. How about -7 and -10? Well, again, -10 is lower in the number line than -7. So it's -7 is greater than -10. Okay? And of course, we have a positive number and a negative number. That's easy. Negative number is always less than a positive number. All right? But don't get confused by the wording, right? This is saying 8 is greater than -10. I could rewrite it the other way. And now you say, oh, -10 is less than 8. So it just, you look at the inequality, but of course, make sure it points to the smaller number. Of course, like for this guy right here, it's pointing to the -10. And what is it pointing to this one? Pointing to the -10, because it always points to the smaller number. Okay? That's not bad. All right, so let's do this is what the worksheet's going to kind of say here, math fans. It's just going to say determine whether the specified or whether the given, I'll say whether the given number is a solution of the inequality. Okay, so this is what's going to be given here. You're going to be given 2x plus 3 is less than negative 4. And then I'm going to give you a number that. I'm going to say, I think it's actually just a comma, negative 3. So truly what it's saying here is I'm saying, hey, when x is negative 3, is this true or false? So let's plug it in. That's all you do. You plug in negative 3 for x. Okay, so let's do that. 2 times negative 3 plus 3 is less than negative 4. So simplified. So 2 times negative 3 is negative 6. And then negative 6 plus 3 is negative 3 is less than negative 4. Is that true? No, negative 3 is actually greater than negative 4, right? It's less negative. Negative 4 is, it should be pointing to the negative 4. So what you're going to say, it says determine whether the given number is a solution. And you're going to say no. No, it's not a solution. Okay? That's easy. So literally you plug it in and you test it. That's it. Okay, so let's try another one here. 5 minus y is greater than negative 4. And I'm going to say y is equal to 8. Again, it might just be comma 8. So again, what are you going to do? You're going to plug it in. Plug in 8 into y. So 5 minus, and then put an 8 there. Okay, and simplify it. So we get negative 3 greater than negative 4. Is negative 3 greater than negative 4? Of course it is. On the number line, here's negative 5, negative 4, negative 3, negative 2, and negative 3 is here, and negative 4 is here. So of course negative 3 is greater than that. So this is true. So if I ask you, is it a solution? You would say yes. It's a solution. Okay? That's not bad. All right. Let's kind of keep going here. Let's talk about graphing these inequalities. So we're going to do kind of a basic graph just to see what it looks like here. Okay? So let's do that. So this is graphing inequalities. You got two different things here. If it's a greater than symbol or a less than symbol, we say it's an open dot. Okay, so you don't fill it in. If it's a greater than or equal to or less than or equal to, it's a solid dot. So we're going to say solid, or sometimes we say closed dot. Okay, that's going to go on the number line. Okay, so just let's do a basic example. X is greater than 5. So it's real easy to graph it, guys. First of all, the variable's got to be on the left-hand side, which it is. So remember how we talked about back in the day? I never wanted you guys to write 5 equals x. I didn't want that. I said you got to say x equals 5. Now we're going to get to the reason why you have to do that is because that x has got to be on the left-hand side for this thing to work. So here's the deal. See this inequality? It makes like an arrow. Okay? So when I graph this on a number line, and by the way, I want you to put 3 points in here. I want you to put the 5 and a point on either side. So 4 and 6. And first of all, it's an open dot. So over the 5, you're going to put an open dot. And then see how that arrow, I told you the arrow points this way because it's the inequality? It's going to point that way. And you're done with the problem. That's how you graph x is greater than 5. Okay? That's not bad. And so I'm going to give you another one here. X is less than or equal to negative 2. Okay, draw the number line. So again, I'm going to put negative 2 in the middle here. This is more negative, so negative 3 and negative 1. Okay, and then it's a solid dot at negative 2. So solid, and then it points that way. So that's your answer. Okay? Not bad. But again, that variable has to be on the left-hand side for it to work. Okay, let me show you why. Here, actually, I can just show you right over here. If I said, instead of x is less than or equal to negative 2, if I said negative 2 is greater than or equal to x, everyone would want to point the arrow this way. Okay, but it's not right. That's actually wrong. You need to rewrite this as x. See how it's pointing to the x? Okay, so it's pointing to the x. When you rewrite it and flip it around, it's got to still point to the x, and then you would be able to graph it correctly. Okay, that variable has to be on the left-hand side. Super, super, super important. Okay, all right, so let's do, let me write that out here again. I think it's important. So variable must be on the left side. Okay, so again, if I said 2 is greater than x, you really can't graph that. You got to say x is less than 2. See, it's pointing to the x. When you rewrite it, it better be pointing to the x. That you can graph. Okay, so that's graphing. Okay, so our last thing we're going to do here is solving. All right, so let's do that. So this is solving. Here's the main rule, math fans. Main rule. Okay, when you multiply or divide by a negative number, what you do is you switch the direction of the inequality. Okay? That's the only difference between an equal to sign and an inequality to solve it, is literally at the very last step. If you divide or multiply by a negative number, you switch the direction of the inequality. Okay? So I'm going to write here again, same rules as equal, what we've been doing the past several days. Same rules as equal. Okay? So let's start out with a problem here. First example, if I said 5x is less than 20, well, how do you solve for x? Just like with an equal to sign. Everything's the same, guys. Divide by 5. X is less than 4. Okay? Nothing happened in the inequality sign because you didn't divide by negative. Let's put next one. Next example here. Negative 5x is less than 20. What do? Divide by negative 5. We are dividing by a negative. So x, and this is going to be 20 divided by negative 5, is negative 4. And you switch the inequality. Look at that. Huh? Okay, so it's important. You got to switch. Switch directions. Very important, math fans. Very important. Okay, so again, I got 4 examples of this almost exact same thing here. So another example, if I said 5x is less than negative 20. Okay, well, I'm going to divide both sides by 5. Am I dividing by a negative number? No. Okay, the 20 is negative, but I'm not dividing. This is not negative. This is positive. So I don't switch the inequality, so I get x is less than negative 4. That's my answer. Okay? So just be careful. I did not divide by negative. All right, and last of these examples, negative 5x is less than negative 20. Well, divide by negative 5. What am I doing? Dividing by a negative number. So x is, and then switch the inequality, greater than, and that's 20. Negative 20 by negative 5 is positive 4. And that's your answer. Okay? So those are kind of your 4 scenarios here, math fans. But the only one where you're switching the signs is where you divide by negative right there, or you divide by negative right there, and then you switch that inequality. Otherwise, you don't switch. Okay? All right, so let's do a couple of friendly problems here. If I gave you guys 5 minus 2x is less than negative 7. So same stuff as doing before. You're moving the variables to the left and the numbers to the right. So I'm going to subtract 5. I get negative 2x is less than negative 12. Divide by negative 2. Ah, there it is. Switch the inequality sign and you get 6. X is greater than 6. Okay? Let's do one with a fraction. Negative 2/3 x is less than 8. Well, how do you get rid of that 2/3? Remember what happens when you have a fraction in front of your variable? You multiply by its reciprocal. In this case here, it's going to be negative 3/2. Oh, what am I doing? Negative, negative 3/2. Okay, so that cancels all this out. We get x, we switch around the inequality. And 8 times negative 3/2, you can do that on your calculator. If you did it manually, you can do 8 over 1, and 8 shrinks down to a 4, because 4 or 2 goes into 8 4 times, 2 goes into 2 once. So you have x is greater than negative 12. Okay, it's not bad. Let's try another one here. So 2x plus 3 times x plus 5 is greater than 7. Remember, it's all the same rules as equal to, guys, except that very last step when you multiply, divide by negative, and you switch around the inequality. So if I do that, I get 2x, and I distribute that 3. So plus 3x plus 15 is greater than 7. Combine like terms. So 5x plus 15 is greater than 7. Subtract 15 from both sides. And we get 5x is greater than negative 8. Okay, it's a little ugly, but no big deal. We're going to divide by 5. Are we dividing by negative? This is negative, but we're not dividing by negative, so we keep the same sign. So we get x is greater than, and you can leave it as negative 8/5, that's okay. Or you could actually say x is greater than, if you put in your calculator, you would get negative 1 3/5, or you can say x is greater than negative 1.6. Any one of those answers is correct. I don't care. Okay? Not bad. Okay. Last problem. Last problem. So if I give you guys 5x minus 2 parentheses x minus 4, and I'll say that is greater than or equal to 4x plus 2 parentheses x plus 3. All right, that looks like a big, nasty, evil problem, like that big alligator eating you before. Okay? Not really, though. Okay, you just got to distribute the negative 2 and distribute the positive 2 on the right side. So 5x, negative 2 times x, negative 2x, negative 2 times negative 4 is positive 8. Okay? 4x, 2 times x is 2x, 2 times 3 is 6. That's it, man. Look at that. Just did all your distributing, and then we combine like terms. So 5x minus 2x is 3x plus 8, greater than or equal to 4x plus 2x is 6x plus 6. Okay, so I'm going to subtract 6x from both sides and subtract 8 from both sides. So this cancels. We have negative 3x. This cancels, and we have greater than or equal to negative 2. Okay, and our final step is to divide both sides by negative 3. So what do we do? There it is. Switch it. So x is less than or equal to, it's basically negative over negative is a positive. So x is less than or equal to 2/3, and that's your answer. Let me clear this up here a little bit. 2/3. Okay. So that's really all there is to do with inequality. I showed you kind of all the things that I'm going to ask you on the worksheet, and you're good to go. All right, my friends, that's it. Have an outstanding day, and don't forget, if you divide by negative, you switch around the inequality. That's the most important thing. If you don't do that, you've learned nothing at all for this unit. Literally nothing, because you're doing everything with an equal to sign, but you're not. It's an inequality sign. So when you multiply or divide by negative, you switch around the direction of the inequality. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.